yeah, move my bed, yeah, move my bed. Kino, soleil, move my bed, yeah, move my bed. Kino, soleil. Move my bed, yeah, move my bed. Bum 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 bum. Bottom. Bottom. Move my bed, yeah. Move my bed, yeah. Move my bed. Kilo, soleil, yeah. Move my baby. Move my baby. Move my bed. Kilo, soleil. Move my baby. Move my baby. Move my bed. Kilo, soleil. Move my baby. Move my baby. Move my bed. Kilo, soleil. Move my baby, move my baby, move my bed.
So here's the thing nobody tells you about building software alone. You don't start with a grand vision. You start with a question, and then another question, and you keep building small things that answer those questions until one day you look back and realize, oh, they were all the same project. This is the story of 6 experiments, 180,000 lines of code, and one developer who accidentally built an AI factory. It started on a weekend. The question was simple. What if you could just point at something on a web page and tell AI to change it? Not write a prompt in a chat window, not open an editor, not file a ticket, just hover over a button, click it, type "make this red," and watch it happen. That became CDD, Chat-Driven Development. 23 files, 5,000 lines. No framework, no build step, no database. Vanilla JavaScript, an Express server, and Claude running as a subprocess. The core loop was almost stupid in its simplicity. Pin an element, chat about it. Claude returns HTML in a fenced code block, parse it, patch the DOM, save to disk. That's it. Pin, chat, patch, save. And it worked. Not in a proof of concept way, in a "this is fundamentally better than writing code" way. The feedback loop was so tight it felt like direct manipulation. You pointed, you spoke, the thing changed. 3 seconds, no context switching. The undo system was 6 snapshots of the full HTML document. Crude? Absolutely. But when your changes are small and incremental, 6 undos is more than enough. Nobody's rewinding 20 steps on a button color change. At the time, CDD felt like a toy, a weekend hack. But what it actually proved was that AI works best when the feedback loop is tight. Show the thing, point at it, say what's wrong, see it change. That interaction model, that was the seed of everything that came after. The next question was different, not about editing, about seeing. If you had 6 specialized AI agents processing a work queue, how would you visualize it? What does an AI agent system look like when you can actually see what it's doing? Mars was pure theater. No real AI, no backend. A front-end simulation with fake agents named Codex and Prism and Sentinel, items flowing through columns like a Kanban board. Intake, understanding, assigned, working, done. But the simulation revealed something real. Keyword-based routing, does the task mention CSS, send it to the designer agent, worked about 70% of the time, which sounds okay until you realize the other 30% fails silently. The task goes to the wrong agent and you don't know it. So Mars added confidence scoring. Every routing decision came with a number between 0.3 and 0.95, and suddenly you could feel the difference. A 0.9 assignment? Trust it. A 0.4? Maybe double check that one. 6 agents turned out to be the magic number. Enough specialization to matter, few enough to remember. Mars was never meant to be a product. It was a vocabulary lesson. It taught the visual language for showing what agents are doing, how confident the system is, and where things are stuck.
And here's the insight it delivered, the one that stuck. If the user can't see what the agents are doing, they don't trust the system. Transparency isn't a nice to have. Transparency is the feature. Then came the big one, the first real attempt at the whole thing.
Chain, internally called Relay V1, was everything at once. Idea capture, AI refinement, agent routing, execution, memory, Git integration, Gitea issues, streaming, a desktop metaphor with a taskbar and a start menu and 5 screens, 75,000 lines of TypeScript, 9,100 lines of vanilla CSS. And it worked. That's the thing people miss. Chain proved the concept. Every feature that would eventually go into the real platform, Chain had a version of it. The local chain library, a lightweight lang chain without the dependency hell, was genuinely good. Prompt template, LLM chain, sequential chain, you could compose AI workflows from these primitives, and they just composed. The agent router upgraded from Mars's keyword matching to TF-IDF cosine similarity. Well, technically just TF, no IDF, but it handled ambiguous tasks better and degraded gracefully when it wasn't sure. SSE streaming changed everything. Watching tokens appear in real time makes AI feel alive. It's the difference between sending a text and having a phone call. Session memory was the real breakthrough. Decisions made in one session, artifacts produced, patterns observed, got injected into the next session's prompts. The AI genuinely remembered what it learned, not through conversation history, through structured knowledge. But 75,000 lines, 9,000 lines of CSS with no design system, JSON flat files that choked at 500 items, auto git commits with no review gate creating commit noise you'd never dig out of. Chain taught the hardest lesson. The feature set is right. The architecture isn't. You need design tokens, you need a real database, you need an execution engine with guardrails, and you absolutely, critically need a human approval gate before anything touches the file system. Chapter 4. Mark. After chain sprawl came the opposite extreme, a Python experiment called Mark, later Loopsmith, with 0 runtime dependencies, not even pip, just the standard library, HTTP server, SQLite 3, subprocess. That's the entire tech stack. The question was radical. Can AI work completely unsupervised? Not supervise and approve each step like Chain tried. Full autonomy. Give Claude an idea, a loop, and a file system. Let it keep trying until it either finishes or hits a wall. The architecture that emerged was elegant. Stateless agent, stateful disk. Each iteration, Claude runs as a fresh subprocess. No conversation history threaded through. No in-memory state. Every single time, the prompt is rebuilt from scratch. Read context.md, read the git diff, read the test output, assemble it all within a token budget, and go. That token budget was carefully tuned. System prompt and PRD always included, never truncated. Project context gets up to 50% of the remaining space. Git diff gets 30%. Test output fills whatever's left. If anything's over budget, it gets truncated with a marker. Zero sum. Adding a new section means something else gets squeezed. The failure diagnosis was where Mark got genuinely clever. After enough iterations, patterns emerge. The same files toggling back and forth, that's oscillation. The agent is undoing its own work. The same test failing 3 iterations in a row, that's stuck. Tests that were passing and now aren't, that's regression. Less than 20% of iterations passing, the task is probably too complex. And lesson extraction. When a test goes from failing to passing, Mark records what changed. It appends that lesson to context.md. Future iterations, future sessions, benefit from past discoveries. It's not machine learning in the statistical sense. It's experiential. The system literally writes down what it learned.
The done signal was the simplest possible thing. Claude creates a file called done_id when it thinks the task is complete. File system-based signaling. No protocol, no handshake. Just, is the file there? Then we're done. Mark proved that autonomy requires exactly 3 things: a way to detect completion, a way to detect failure patterns, and a way to accumulate knowledge. Without all 3, the loop just spins. Chapter 5. Limitation. And then there was the wild card. Limitation wasn't a developer tool at all. It was an art project. 54 procedural 3D worlds, themed around verbs and concepts. Cities that pulse with music, landscapes that respond to your body, spaces you navigate with hand gestures. But it kept growing features that looked suspiciously like a platform. The composable world building was the key insight. 5 factory functions: create themed city, create themed ground, create themed horizon, create themed particles, create themed moon, could generate any of those 54 worlds by tweaking parameters, not copy-pasting code, composing it. Audio reactivity ran on 4 numbers: bass, mid, high, energy. Every visual component in every world took those same 4 numbers and did something different with them. A building might pulse its emissive glow with the bass. Particles might scatter faster with energy. The interface was 4 floats. The expressiveness was infinite. Media pipe, face tracking, hand tracking, pose tracking, all running in the browser. The performance trick was alternating. Face detection on even frames, hand detection on odd frames. Half the CPU cost, barely noticeable visually. Gesture control worked. Grab detection, 3 or more fingers within 0.08 distance of the palm center. 2-hand zoom via the angle between hands. Edge zone navigation with a hold to trigger delay to prevent accidental activation. And body as input device. 33 skeleton joints tracked in real time, used to push physics objects in the 3D scene. The visceral connection of moving your actual body and watching digital objects respond, that's something a mouse click can never replicate. Limitations lesson was the most surprising. Developers spend 8+ hours a day in their tools. Those tools can be beautiful, spatial, and responsive to the human body. That's not a luxury, that's retention. Your project catalog doesn't have to be a list. It could be a city. Your agents don't have to be rows in a table. They could be ships. Your progress doesn't have to be a bar. It could be a world that changes. Chapter 6. Bibliothèque. The last experiment was the quietest one. It started as a project cataloger. Scan your local codebases, count files, count lines, store some snippets. Knowledge management for a developer with too many projects. But Bibliothèque kept growing. A tab system, then a side panel system, then an activity bar, then a status bar. Suddenly it was a VS Code style IDE shell, running as a native desktop app on Rails v2, Go backend, embedded Chromium frontend, every Go method on the app struct automatically available in JavaScript. No API layer, no HTTP, just call the function. SQLite with foreign keys handled everything. 15 tables, cascade deletes, one init schema function. The data layer was solid in a way that chains JSON files never were. The relay design system emerged. Portable, zero-dependency TypeScript tokens, tokens.color.backcard, styles.card, statuscolor.success, type safe, consistent, extractable. Copy the file into any project and it just works. And then the work queue engine. Plan, execute, verify, reflect. The executor interface. Write file, edit file, run command, ask Claude. Meant you could mock everything in tests and use real I/O in production. 48 tests, all passing.
The plan approval gate was the lesson Chain taught. Generate idea plan shows you the steps. Approve plan is the human saying yes, modify my files. Without that gate, autonomous execution is a liability. Agent memory started as rows in a database table. Pattern, context, outcome. Crude. But when those patterns get injected into future plan prompts, the system starts to improve. Not dramatically, not magically, just the factory remembers what worked and what didn't. Bibliothèque proved that the shell matters more than any single feature. Get the tab system right, get the data layer right, get the design tokens right, get the execution engine right, and every feature you add later just snaps in. So here's the thing. Look at those 6 projects on a timeline. CDD asked, can AI edit live UI? And it proved the pin chat patch loop. Mars asked, what do agents look like? And it proved Kanban boards with confidence scores. Chain asked, can it be one app? And it proved yes, but also proved you need real architecture. Mark asked, can AI run unsupervised? And it proved stateless loops with failure diagnosis. Limitation asked, can the workspace be a world? And it proved 3D, audio, and body tracking all work in the browser. Bibliothèque asked, what's the container for all of this? And it proved the IDE shell with a proper engine underneath. 6 experiments, 6 questions, 6 answers. And together they answer the only question that actually matters. Can a single developer, working with AI agents, produce at the scale of a team? The experiments say yes. Look at the numbers, 180,000 lines of code across 584 files, 52 features cataloged and working, 289 automated tests passing, 4 different languages, 6 different persistent strategies, 3 different AI integration depths, 1 developer. Each experiment was prototyping a feature of a system that didn't have a name yet. CDD was the design studio, Mars was the agent dashboard, Chain was the router and memory layer, Mark was the execution engine, Limitation was immersive mode, Bibliothèque was the platform shell. 6 experiments, 6 features, 1 factory. The factory has a name now. Relay. It's not a product yet, it's a blueprint, a set of proven patterns, tested code, and hard-won lessons assembled from a year of experiments that didn't know they were building the same thing. The specs are written, the data structures are defined, the prototype is clickable, the architecture is clear. What happens next is engineering, taking the lessons from Chain's sprawl and Mark's discipline, taking the visual language from Mars and the interaction model from CDD, taking the composability from Limitation and the solidity from Bibliothèque, and building the real thing. 1 developer, AI agents that plan, execute, verify, and learn. A system that remembers what worked, a workspace that could be a world. That's the factory, and the factory is open. Relay.
2026. 6 experiments. 1 system. The loop continues.
bum move my baby. Bum move my baby. Bum move my baby. You know, so late now. Bum move my baby. Bum move my baby. Bum move my baby. You know, so late now. Bum move my baby. Bum move my baby. Bum move my baby. You know, so Layla. Bum move my baby. Bum move my baby. Bum move my baby. Bum so Layla. Bum move my baby. Bum move my baby. Bum move my baby. So Layla.
Bum move my baby. Bum move my baby. Bum move my baby. Kina Soleil. Bum move my baby. Bum move my baby. Bum move my baby. Kina Soleil.
Bum move my baby. Bum move my baby. Bum move my baby. Kina Soleil. Bum move my baby. Bum move my baby. Bum move my baby. Kina
éternel, sou pas vini m'pas capable, ou pas vini kounye à poudre.
my bay, ba-dum, move my bay, ba-dum, move my bay. Kine, soleil, move my bay, move my bay. Kine, soleil, bum 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 bum. Ba-dum, ba-dum. Move my bay, move my bay, move my bay. Killer soleil, move my